Good morning students. Today we are going to continue our topic. Today till now from the last two lectures we were discussing about the ANOVA, but today we are going to solve by means of solving one example. So we are going to understand the basic concept of ANOVA, that is analysis of variance, by solving one example. We already know the 9 steps of calculation of the ANOVA, of which the first step is set up the null hypothesis and the alternative hypothesis. So yesterday we have already covered this first step, that is null hypothesis as well as the alternative hypothesis. So the null hypothesis represented by HO, and it shows there is no significant difference in the average yield under the three varieties, and we have to set up the alternative hypothesis also, which is just opposite of that of the null hypothesis. So alternative hypothesis is the difference in the average yield is significant. We have to consider as an alternative hypothesis. So we have to make 3 columns, and then we have to divide each column into again 2 divisions. So the first column, that is a sample A, next is a sample B, and third column is the sample C. So the next step includes, that is calculate the total T of all the observation in all the samples. So we have to find out the capital T. That is nothing but we have to do the summation of all the observations. So here we have to sum up all the observation of a particular sample of all the 3 samples, that is sample A, sample B, and the sample C. So this is nothing but the second step, that is calculation of the T. You know that T can be calculated by means of the formula, that is summation of x1 plus summation of x2 plus summation of x3, because only 3 samples are given. So we have to total all these sample 1 plus sample 2 plus sample 3. So the totaling of all will gives you 92, that is summation of x1 is equals to 92 plus summation of x2, that is equal to 72, and what is the summation of x3, that is equal to 100. So what is the total T? That is equal to 264. So we got the T is equals to 264. Now coming up to the next step. Next step is nothing but the correction factor, that can be calculated by the formula T square by N. So the correction factor, that is T square by N. What is T? T is, we have calculated, that was 264. That is 264 square divided by N. N is the number of sample, total number of sample. So we know that 4 plus 4 plus 4. 1, 2, 3, 4 in sample 1. Again 4 in sample 2 and 4 in sample 3. So total number of samples, each and every observation, number of observation, that is equals to 12. Therefore we can write it down 264 into 264 divided by 12, that equals to 5808. So the correction factor, that is T square by N, can be calculated as, and we got it as 5808. So the next step is we have to calculate the SST. So SST can be calculated by means of summation of x1 square. So we have to find out the square. So here we did the squaring of each and every observation. So we have to square all this number and then we have to add it. So what is the SST? SST is equals to, first that is 2126 plus what is the next value, that is 1306 plus next value 2552 minus the, that is t square by n. So what we got the value, t square by n, that is equals to minus 5808. So what will be the value altogether, that is 5984 minus 5808, that equals to 176. So we got the SST, as 176. Now we have to move on to SSB. We know that what is the value of SST? SST value is 176. And what is the value of t square by n? That is nothing but 5808. Now we have to find out the SSB. That is next step, that is fifth step. So in order to calculate the SSB, according to the formula, SSB can be calculated as summation of x1 whole square. So what is x1? 92. So we have to multiply 92 with the same number, that is 92, that is 92 square divided by n1. What is n1? Number of observation in sample 1, that is equals to 4. Again, what is the summation of x2? We have to square it. Therefore, summation of x2 is 72. So, square it divided by, again here, number of observation in sample B, that is equals to 4. Next is 100 into 100 divided by 4 minus, here it is minus t square by n. We know that t square value we got it as t square by n as 5808. So after subtracting the whole number, we will get the value 5912 minus 5808, that is equals to 104. So what is SSB? SSB, sum square between the sample, that is equals to 104. What is the next step? The next step, that is, now we have to calculate the SSW. We know that SSW is equal to SST. So we have calculated SST and it was nearly about 176. And just now we have calculated the SSB, and which is 104. So when we subtract these two terms, then we will get as 72. So what is SSW? SSW is nothing but the 72. Now moving up to the seventh step, that is, now we have to calculate the M.sc. But before that, we have to find out the degree of freedom. So degree of freedom can be calculated by means of V1, that is equals to K minus 1. So that is degree of freedom. So degree of freedom is equals to, what is K? K is the number of samples. So we have 3 number of sample minus 1, that is equals to 2. So degree of freedom, that is V1, we got it as 2. So MSB, mean square deviation between the sample, is equal to SSB. We know that what is SSB? 104. So 104 divided by degree of freedom, that is V1, that is equals to 2. So we will get it as 104 divided by 2 is equals to 52. So we got MSB as 52. Next step, that is, in the same case we have to calculate the mean square with the sample, within the sample, MSW. So we have calculated MSW B. Now we have to calculate the MSW. So we got SSW here, that is 72. So 72 divided by V2. So in order to calculate the V2, what is the formula of V2? N minus K. N is nothing but the number of observations. So altogether we have N1 first observation, N2 second observation, and first sample observation, second sample, and in this way third sample observation. Means altogether we have 12 observation minus how many sample? 3. That is equal to 9. So what is V2? V2 is 9. So we have to here divide 72 divided by 9, that is equals to 8. So 8 is nothing but, so coming up to the steps of calculation, that is second last step of the ANOVA. Here we have to find out the F. So F can be calculated by means of dividing the MSB divided by the MSW. So all the calculated values should be represented in the form of a table. So here we have calculated T value, that is equals to 264. So T value, that is equal to 264. Correction factor, we got it as 5808. SST, that is 176. SSB as 104. Degree of freedom, that is 2. Next is MSB, mean square between the sample, that is equals to 52. SSW as 72, as well as the MSW as 8. So we got all this value after the calculation. So we have to tabulate all this value and then we have to find out the F. So F, what we got it as? M. So you can find out certain columns. First is the source of variations. So between the sample and within the sample are the two sources of variation. Sum of the square, that is SSB and SSW, we have calculated. Next is the degree of freedom. First one is n minus 1, the number of sample minus 1, and the within the degree of freedom within the samples, that is total number of observation minus sample 3. 12 minus 3 we have calculated. So next is the column about the mean square. We got it as MSB as 52 and MSW as 8. Now that is the last step, that is the finding the F. So F is equal to MSB, that is equal to 52. MSB, that is equals to 52 divided by, what is MSW? That is 8. So 52 divided by 8 will got it as 6.5. So what is the value of F? F is equal to 6.5. Now the last step in the calculation of the ANOVA is nothing but we have to compare the calculated value with the tabulated value. So here what is the tabulated value? At degree of freedom 5%, F, what is the F given? That is 4.26. And what we got the calculated value? That is nothing but the 6.5. So this is the calculated value. And 4.26 was the tabulated value of the F. So how do we conclude the example? That the calculated value of the F at 0.05, at 5% we have taken now. So 5% can be written as 5 by 100, that is equals to 0.05. That's why here it is taken 0.05. So the calculated value of F at 0.05 at degree of freedom V1, that is equal to 2, and V2, that is equals to 9, is 6.5. So here we got the calculated value, that is 6.5, and we know that it is much greater than the given value, that is equal to 4.26. We know that it is, this calculated value is greater than the tabulated value, and hence we reject the null hypothesis. So I already said that if the calculated value is greater, then we used to reject the null hypothesis. Hence we accept the alternative hypothesis. Hence we reject the null hypothesis at 0.05 level and conclude that the difference in the average yield under the three varieties is significant. So remember what I said regarding the conclusion is that if the calculated value is greater than the tabulated value, we know that our calculated value is greater than the tabulated value. So we used to reject the null hypothesis. What was the null hypothesis? Null hypothesis, there is no significant difference in the average yield. So we used to reject this. So we can say that we reject the null hypothesis and we say that it is significant, or we used to accept the hypothesis of the significant. We say that it's. So the conclusion will be in this way. So here, hence we reject the null hypothesis at 0.05 level and conclude that the difference in the average yield under the three varieties is significant. So this was regarding the how to solve an example related to the ANOVA. So next example is given to you tomorrow. You just try to solve it. If there is any problem, I will let you know. Thank you and see you on Monday. Tomorrow is a holiday, that is Sunday. So see you on Monday with the next topic. Thank you and happy Dasara.